Have you ever really stopped to wonder what's going on inside your own head? We kind of think of our brain as this fixed, mysterious command center, right? But what if I told you it's actually more like a living, breathing city, one that's constantly rebuilding and rewiring itself every single moment of every single day? Okay, let's get into this. There's this really common idea that by the time we hit adulthood, our brains are pretty much set in stone, that the hardware we've got is just what we're stuck with. Well, science has shown us that old way of thinking is just plain wrong. Your brain has a secret superpower, and that superpower has a name: neuroplasticity. Now, this isn't just some fancy science term. It is the fundamental principle that allows you and me and all of us to learn, to change, and to grow for our entire lives. So, what does that actually mean in plain English? It means your brain is incredibly, well, plastic. It's malleable. Every single time you learn a new skill, or you hear a new idea, or even just have a new thought, you are physically changing its structure. You're literally creating new roads and reinforcing old highways in that city inside your head. And this isn't just for kids. This keeps happening well into our senior years. Okay, so how does this incredible rewiring actually happen? If you've made it this far, there's no reason not to like the video and subscribe to the channel so you don't miss what's coming next. Probably the best way, the most relatable way for us to understand neuroplasticity in action is to look at how we form a simple memory. It's the very engine of change in our brains. At the very heart of all this rewiring is a simple but really profound idea, and it's captured perfectly in this one phrase. This principle, which scientists call long-term potentiation, is basically the bedrock of learning. When brain cells, neurons, talk to each other over and over again, the connection between them gets stronger. It's kind of like turning a faint little footpath in the woods into a 6-lane superhighway. And believe it or not, this process is happening all the time. Let's say you meet someone new. First, your senses perceive them, you see their face, you hear their name. Those signals then zip off to a central hub in your brain called the thalamus, which kind of weaves them together into one single experience. Then the hippocampus, let's call it our memory headquarters, analyzes it. Is this important? If you think, hey, this is my new boss, the hippocampus flags it as definitely worth storing. And bam, the brain rewires itself, strengthening the connection for that face and that name. A memory is literally born. Now, this rewiring isn't magic. It's all chemistry, driven by these little messengers called neurotransmitters. You can think of acetylcholine as the focus chemical. It helps you pay attention. Glutamate is the main go signal, making the connections actually happen. Noradrenaline helps you encode that new info, and dopamine comes in to reinforce the learning, basically telling your brain, hey, that was useful, remember it. But as powerful as this whole system is, it's not invincible. As we get older, the process of aging introduces a whole new challenge. What happens when the blueprint for this incredible dynamic city inside our heads begins to fade? Okay, let's be really clear about something that, worries a lot of us. Forgetting where you put your keys sometimes, or taking a little bit longer to remember a name. That could be a totally normal part of getting older. But this idea that a severe, serious cognitive decline is inevitable, that is just wrong. So the crucial question is, where's the line? So here's the difference. Normal age-related memory loss doesn't stop you from living a full, independent life. You can still handle your day-to-day stuff. Dementia, on the other hand, is a progressive loss of cognitive function that gets so severe it actually interferes with your daily life. We're talking about a much, much more significant decline. And certain things can weaken our brain's plasticity, making it more vulnerable. Chronic stress is one of the worst culprits. It directly damages the hippocampus, our memory center. What we eat matters a lot. Diets high in saturated fat are linked to a much higher risk of dementia. And other health issues, like problems with your thyroid or diabetes, can also really impact our brain's ability to function and adapt. But what happens when these processes don't just get weaker, but they start to break down entirely? This is when we enter the terrifying realm of neurodegenerative disease, where the very connections that make up who we are begin to sever. The scale of this problem is, well, it's staggering. An estimated 50 million people right now around the globe are living with some form of dementia. This is a global health crisis that touches millions and millions of families. Now, it's really important to get this. Dementia isn't one specific disease. It's more of an umbrella term. It describes a whole collection of symptoms that happen when abnormal changes in the brain start damaging our neurons and mess up their ability to talk to each other. And when that communication breaks down, so does our ability to function. And while there are a lot of different causes, one disease is responsible for the vast majority of cases. Alzheimer's. It accounts for a shocking 60 to 80% of all dementia diagnoses. It's by far the most common and well-known form. The devastating impact of dementia is often broken down into what's called the 4 A's. There's amnesia, which is memory loss, aphasia, where language becomes difficult, agnosia, which is the inability to recognize familiar things or people, and apraxia, the loss of ability to do simple learned movements like getting dressed. And this brings our whole story full circle. Remember the hippocampus, the brain's memory headquarters we talked about at the very beginning? Well, in Alzheimer's disease, this is one of the very first areas of the brain to get damaged. And that is precisely why memory loss, that breakdown of the fundamental process of plasticity, is so often the very first sign that something is terribly wrong. So we've explored the brain's incredible power to change, and we've looked at the devastating consequences when that power begins to fade. And it all leaves us with the most important question of all. Now that you know what the stakes are, do you know how to care for your brain and protect it? Well, the good news is you absolutely can. We've put together a whole explainer on the science-backed strategies to help boost your brain power and lower your risk. You can find out exactly how in our very next video. If you've made it this far, there's no reason not to like the video and subscribe to the channel so you don't miss what's coming next.